problem 1.7, proof by induction the following statements valid for all natural numbers n greater than 1. Okay, so in this case it's different from other induction problems in that the first case we will have to use as a test is not n equals 1 but n equals 2. Okay, so these statements, they can not hold for n equal 1, and maybe they will not. Okay. So let's start with the first one. Okay, n factorial is smaller than n plus 1 over 2 to the nth power. Okay. So, and there's a hint here. This is in A, use the inequality 1 plus 1 over n plus 1 to the n plus 1's power greater than 2, which is valid for all n equal, L a natural number. And this, we're given this, we don't need to prove this. But I'm gonna play with this a bit so that it's easier to use later on. So this is, we can write this way. Let me write it here. So this is n plus 1 plus 1, so n plus 2 over n plus 1 to the n plus 1 power greater than 2. Or in other words, we can write this like this: 2 divided by n plus 2 n plus 1 to the n plus 1 power is smaller than 1. Okay, so this is the same statement that we're given in the hint, but it will be useful for when I deal with this. Okay, so here, first thing we need to do is to prove it for the basic numbers. So in this case, n equals 2. For n equals 2, we have n factorial, which in this case this is 2. And then we have n plus 1 over 2 to the n, which is, in this case, is 2 plus 1, 3 over 2 squared. So this is 9 over 4, and this is greater than 8 over 4, sorry, which is 2. Okay, so in this case it holds. N plus 1 over 2 to the nth power is greater than n factorial when n equals 2. Okay, and now we need, the next induction step is to assume this is true. So we are going to take this for granted for some n, and we want to prove this for n plus 1. Okay, so is this true for n plus 1 factorial is smaller than n plus 1 over 2? So yeah, sorry, what we need to prove is this true? Is true? We don't know. Okay, so let's start with this, and then do some algebra. Try to introduce the induction hypothesis at some point and work further. And we know we're going to have to use this, okay? Because otherwise, they wouldn't have given us this inequality. So we know n plus 1 factorial is just n plus 1 times n factorial. Okay, that's the definition of the factorial. And we know n factorial is smaller, so we know this is n plus 1 times this, smaller than this. N plus 1 to the nth power over 2 to the nth. Now, this n plus 1 times n plus 1 to the n is just n plus 1 to the n plus 1 over 2 to the n. And now what we want is, as you remember, what we want this expression to be, well, let me write it here maybe. We want to prove this: n plus 2 over 2 to the n plus 1. This is what we want to prove, okay? But as you can see here, n plus 1 factorial smaller than n plus 1 to the n plus 1 over 2 to the n. So we don't have any expression of the somehow like n plus 2. Okay, so what I'm going to do, and this is kind of like an old trick, is to just multiply everything by this. Okay, n plus 2 to the n plus 1, 2 to the n plus 1, and then divide it by it. Okay, so if you multiply and divide an expression by the same number, you will have the same expression, right? Unless it's 0. Okay, you can't do that with 0, but we know this is not 0. Okay, so in this case what we have is see. We're going to have, let me get my bearings here. We want to use this expression, okay, here. So let's see. 2 to the n, I'm going to use the eraser, okay. 2 to the n plus 1 here and 2 to the n are equal to in the numerator, okay. And now we have this expression in the middle, which is the one we want to be smaller than. So this is a smaller one than this thing here, n plus 2 to the n plus 1, and then 2 to the n plus 1, and then multiplying 2 over n plus 2 to the n plus 1. But then we have this factor that is multiplying, but we can divide by it, take it dividing here in the denominator, okay? But this thing here, now is where we use the hint. This expression here is the same as this one here. And we know because of the hint, this is smaller than 1. So all this thing will be smaller than this, which is what we wanted to prove, okay? So we have gotten n plus 1 factorial is smaller than this, which is what we wanted to prove, and this ends the proof.